Welcome to Building Content Knowledge in Mathematics. My name is James and this is episode 2 where we're going to be focusing on the topic of area. Our learning intention today is to explore a learning trajectory for the teaching of area measurement, to understand the key ideas that underpin area instruction, and to develop a bank of strategies and activities for teaching area measurement. Now today we're going to be looking at an article that I wrote in 2021. The way that the article came about was that I was doing a course, Leading Mathematics Planning at the Basto Institute, now the Victorian Academy, through facilitators Anne Gervasoni and Ailey Davidson. And what I had to do was engage in an action research project. So the action research project that I looked at was the teaching of area measurement and how we go about it. So I had a look in the textbooks, the textbooks that are out there today, and I couldn't find anything that told me a really straightforward learning trajectory for teaching area measurement with validity to help students really to develop depth in their understanding of area measurement. So we're going to be going through that today, and I'm going to be elaborating on a few things because my thinking has evolved and changed over time as I've synthesized new knowledge. I've come to new thoughts and new realizations. So I'll be sharing those with you today. So many authors have suggested that students struggle with their understanding of area. They confuse area with perimeter and progress from junior to senior years of schooling with a superficial understanding based on instrumental length by width rules. Irwin contends that more time needs to be taken when transitioning from informal to formal measurement, and building knowledge in sequence is extremely important. So a few things there. First thing, students struggle with understanding area. They confuse area and perimeter. So we've got to make sure that we're teaching area and perimeter together. So we can iron out those misconceptions and we can really create a strong foundation and a strong understanding of what area measurement is so that students aren't confused. We've got to spend more time in the informal stage before we go to the formal stage of measurement. And the reason why is because knowledge builds in sequence. What I like to do is I like to build knowledge over time and make sure that I have anchor points for my students. So how am I anchoring their learning to the previous learning that they have learnt? How am I anchoring to their long-term memory? And we do that sequentially. So a lot of research has found that, Simon in 1995 found that students could cognitively employ procedural knowledge, so that length by width rule, when justifying their responses to an area activity, but the knowing of what area was eluded students. So students are able to use that procedural knowledge, but that depth of understanding just isn't there. So my suggestion and my opinion is take that time. We have time as teachers in the classroom. Take that time to develop the foundations. Develop the foundations and then build on those foundations over time. That's just my opinion. I'm not really big on throwing procedures straight at students. I like to sequentially build knowledge over time. And that's what a learning trajectory is really all about. Making sure that we're taking students through a learning sequence or a course of learning that helps them to develop depth with their understanding. Now, once again, I'm not saying procedures are bad. So there's a bit of discussion out there, procedures versus procedural versus conceptual understanding. Yes, they should be taught in conjunction with one another. 100%. We shouldn't be afraid of procedures, but also we need to be making sure that we're teaching content in sequence. Okay, making sure that we're layering content over lessons. And once again, retrieving and coming back and building on that knowledge over time. My opinion is just wait a little bit before you start to introduce that length by width rule so you can develop that strong ground game. Now, people will say, James, I'm just going to teach my kids length by width and we're just going to get straight into it because I'm not wasting time. I think that's the wrong idea to take, the wrong path to take, purely because if we develop background knowledge, if we develop a strong understanding through, for example, the concrete pictorial abstract, if we develop that understanding through the concrete, it helps to build their understanding over time. And then when they get to the abstract won't be as abstract because they'll have those rich experiences to draw from in their long-term memory. That's just my opinion. So the learning trajectory today. So the learning trajectory that I proposed was that we develop students' understanding of comparison, and then manipulation of concrete materials, then manipulating square tiles, and I'll go into why manipulating square tiles is actually a really important part of the sequence, and then using prototypical grids, and then invented strategies and partial units with non-prototypical grids. I'll get into that as we go. If you're confused a little bit, we'll get into that as we go. So making sure also on the left-hand side, I've said that we need to integrate perimeter throughout the sequence of learning. So making sure we're teaching area and perimeter at the same time to iron out those misconceptions and create a clear understanding for our students what is area. Also, we need to be looking at estimation. So we know from the research that the more students estimate, the better they become at estimating. So please make sure you're using estimation throughout your sequence of learning. So first port of call is looking at comparison. Students already arrive at school with an ability to compare objects. They notice attributes of measurement and they perceptually directly compare objects. Before students think about physically manipulating concrete materials, they should use their reasoning skills to develop comparative language and consider why and how objects have a larger or smaller area than others without using grids or discussing the area formula. Overall, the development of mathematical vocab helps students become actively engaged in mathematics. Developing vocab first helps students to talk about a topic in a meaningful way. So, the main two take-home points here is this. We need to be developing a mathematical language. The only way that we can reason and talk about mathematics in a meaningful way is by developing the language first. If we develop the language first, then we can get students to reason and talk about mathematics in a really rich way. The second thing here is looking at comparison. Before we start manipulating concrete materials, let's start comparing things. So for example, the activity that I have here at the top is I got students to cut out palm prints, and then I put them on top of square black paper. And then we compared how much area a palm print covers the black square. Which one covers the most area? So we looked at 3 different handprints and we discussed different ideas of talking about area. So the language of narrower and wider, for example, are really nice ways to talk about area. So making sure the first thing that we want to be doing is we want to be comparing objects through overlaying objects. So for example, if we overlay a palm print, we could overlay a footprint and just have general discussions about which one covers more surface, which one covers more area. Another little thing I want to talk about is this idea of covering. If we talk about area later on as being the space within a 2D shape, if we talk about covering is a nice word to discuss before we launch into formal discussions of area. So I hope that makes sense. So manipulation of concrete materials, so informal units of measure. It is widely believed through research that concrete materials have a positive effect on student learning. Concepts such as iterating, measuring with no gaps, identical unit, and appropriate unit of measure can be explored in lessons involving the physical manipulation of resources such as cards and dominoes. When building knowledge, we need to anchor new knowledge to a foundation. Using the word covering, once again, like I said, helps to bridge to the formal idea of area being the measurement or the measure of the amount of space enclosed by a 2D shape or two-dimensional shape. If we have a look on the left-hand side, here's manipulation of concrete materials. So what I've done here is I've given students dominoes and I've given them playing cards, and I said to my students, how many dominoes cover my book? How many cards cover my picture storybook? Then I got students to cover tables, cover their chairs. How many informal units of measure cover these objects? So this is a nice way to start talking about area and layering in, having that idea of covering and then moving into those formal methods. So get students to cover objects or cover surface area with informal units of measure. When we're talking about informal units, we're just talking about concrete materials like your dominoes, like your playing cards, might be an A4 piece of paper. So this is a really nice way of talking about those concepts of measure, such as iterating, measuring with no gaps, identical unit, and appropriate unit of measure that you can layer in your classroom discussions. It's nice. These are nice little activities that you can roam around the room and start to, really shift student thinking to understand, hey, when we measure, we make sure we measure with no gaps. We make sure we use the same unit. We make sure we use an appropriate unit. For example, you're not going to use dominoes to measure a basketball court. That's a very extreme example, but you get the idea. Okay, counting and manipulating square tiles. So I put this as the next part of the learning trajectory because square tiles are a nice bridging point between the informal and formal. So square tiles help to transition from the concrete to the pictorial in that concrete pictorial abstract model. They help to shift student thinking from informal units to formal units of measure. So a task that I got students to do was a bit of an open-ended task. A rectangle has 16 tiles. How might it look? So we've got a rectangle, and we know a square is actually a square rectangle by definition in geometry. So we actually have a 4x4 grid there, and we have a 2x8 grid down the bottom. So encourage students to focus on the idea of square units and the connection of area to arrays. Now we can start talking about that multiplicative thinking, that 4 times 4, 4 4 is 16, 16 square centimeters or 16 square tiles. So we can start talking about those formal ideas. So using square tiles is a nice bridging point. The idea here is using square tiles to bridge from the informal to the formal. Then we have using prototypical grids. Prototypical essentially is your standard grid. The prototypical grid is your square centimeter grid paper, for example. So this is a sample of a student's piece of work. The activity asked the students to draw a bird's eye view of their bedroom, and they had to calculate the area of the furniture. This is a nice starting point because students are just counting squares. That's your real starting point when you're looking at those formal units of measure. So we can see that the bed is 6 square centimeters. We can see a side table is 2 square centimeters. And we can see the wardrobe along the bottom there. I also got them to calculate the area of the carpet as well. So this was done with grade 2 students. This was done back in 2021 with grade 2 students. Then I've expanded on the article more as I've taught all across different areas of school. So for example, this is you're more moving up into your senior years of schooling here, but still I wouldn't be holding students back. If you're teaching area, I'm a big believer, don't teach your year level. So if you're a grade 3 teacher, you know that there's going to be students in your class 1 to 2 years above and below where you're at. Teach the content, don't teach the year level. That's a big one that I have discussions with at my school and previous schools. Teach the content. It really unshackles you from being held within bounds of your year level. So teach the content, teach the actual subject of mathematics. That's just a little piece of advice there. So using prototypical grids, how do we build a student's understanding of area? So counting squares, additive thinking, start with students counting squares. All right, we've got 16 centimeters squared there. We know that if we counted each square, we'd have 16 squares. And then also you've got triangles in there. You can count triangles, squares, and then we can count 2 halves of a square to make 1 full square, which is the plus ones on the right-hand side there. So we can see that 6 squares plus 1 is 8 centimeters squared for that right-angled triangle. Then after that, we move into formal methods. Actually, before we move on to formal methods, looking at multiplicative thinking, The additive thinking is interesting. I went into a prep classroom and I put that 16 centimeters square grid up on a whiteboard, and all that students did was they counted squares. We just counted squares. Imagine if you just started getting students to count squares, because we know counting is a part of the prep curriculum. Imagine if we got students to just count squares, grid squares, as a part of their counting routine in primary school. By the time they get to like, you know, the middle years, 3, 4, 5, 6, you've already primed them with a bit of understanding, a bit of knowledge around calculating area. It's a really nice thing to think about. Okay, so number 2 is those formal methods, that multiplicative thinking. 4 rows of 4 is 16 centimeters squared. And then I like to stretch that formal thinking, which I put into under 2A, with calculating a missing side. So if I have an area of 14 centimeters squared and one of my sides is 7 centimeters, what is the other side? And the same down the bottom there with 14 centimeters squared. I've got 2 centimeters on my right side. What is the missing side? Then we go on to adding parts. So we've got those formal methods. 5 times 2 is 10, 2 times 2 is 4, 4 times 2 is 8, 10 plus 4 plus 8, 22 centimeters squared. So what we're doing is we're calculating, we're adding the blue, white, and the purple together, and then we are calculating the total area. Something that students and teachers aren't thinking about, and I'm really surprised when I talk to teachers about area, is they're not using deficit thinking. It's such a great tool. So what I like to tell my students is, all right, if you have an irregular shape, make it into either a square or a rectangle, and then subtract what is missing. So for example, we've got 5 times 6 is 30 centimeters squared. We take away 8 centimeters squared. We have 22 centimeters squared. If we have a right angled triangle, we can make it into a square and go 4 fours is 16. Half of 16 is 8 centimeters squared. Makes it really simple, really easy for students to calculate the area of irregular shapes just by using deficit thinking. So use deficit thinking. Make sure you're teaching deficit thinking. It's a really, really impactful tool when it comes to calculating area. So invented strategies and partial units with non-prototypical grids. So partial units, those parts that are not whole squares. So any strategy that does not involve using the standard written algorithm or counting by ones is regarded as an invented strategy. It is suggested that students first develop invented strategies as a bridging point to the discussion of formal area formulas. Invented strategies are at the core of fact fluency, and the same could be said for measurement fluency. Van der Waal et al. Suggests students make fewer errors using methods they understand, can develop their number sense, and require less reteaching when using invented strategies. So invented strategies are really nice. Do I believe we should be using invented strategies straight up? I don't know. I'll be honest with you, I don't use invented strategies straight up because I like to build knowledge over time. Once again, I'm a big believer. Success fuels motivation. The more we can motivate students, the more likely they are going to engage in the content that we are teaching. So I'm a big believer. Let's build that knowledge capacity over time. And then I like to get the invented strategies at the end, which is what I did here. So I gave students a quick shape that I drew up in black pen, and I said, aside from the formula that the ideas or procedures that I've taught you, what is an interesting way that you could find the area of these irregular shapes, or this irregular shape? So student 1 skip counted. They started off, if you look down the bottom, they've got the partial units there, and then they've also skip counted and they've gone 2 plus 4, 4 plus 6, and so on and so forth. So skip counted. Then student 2 wasn't really an invented strategy because I had already shown them how to add adding arrays together. So you can see that they broke their box up into pink, blue, orange, and yellow, and they calculated the area of those squares and rectangles the square and rectangles, and then added them together. So in terms of an invented strategy, nice way of thinking about it, but not really so much an invented strategy. Student 3, though, did something interesting. They calculated the area of one triangle and then multiplied that triangle by 4, which I found pretty interesting. So they calculated the area of one triangle and then multiplied it by 4 because they broke the shape into 4 different triangles equal in size. I found that to be an interesting strategy. But anyway, what I would say is make sure that you give students irregular shapes to calculate the area of, and just see what they can do. Students really, I find over the years, I found students really surprise you in terms of what they can deliver and what they can show you with their thinking. So that's come to the end today. We're going to review the content and discuss how to teach area. So start with language of comparison, and build that vocab wall. Create a nice vocab wall that you can draw on for your students. Teach perimeter at the same time as area to continually reinforce the difference between the two. Really make sure you're reinforcing the difference between area and perimeter continuously. Continually estimate throughout the learning sequence. Okay, roughly estimate how many dominoes cover this writing book, and then find the correct amount of dominoes. Find the answer. Layer in the language of iterating, identical unit, appropriate unit, and measuring with no gaps, making sure that we're building in that understanding those length and measurement ideas. Don't jump to formal methods too quick. Build background knowledge through experiences with lots of opportunities to cover surfaces. If we build that knowledge, build that understanding, and then they've got a really strong ground game before you implement and show them length by width, then you go, I feel you do a service to your students. Teach the different strategies, counting by ones, the formal method, adding parts, and deficit thinking. Once again, deficit thinking, I don't think it's really being thought about in primary school as a strategy for calculating area. Make sure you're teaching that. Stretch students to find the length of an unknown side by connecting to multiplication. So going deeper with those formal methods. Invest in building student knowledge and resist jumping ahead too quickly. We just talked about that. Build knowledge first to help anchor formal methods later. Engage in retrieval of previously learnt content to strengthen long-term memory. So as you engage in a new lesson, always be going back and revisiting, helping students to draw from their long-term memory. Also, another thing I like to do besides doing a vocab wall is I like to build an anchor chart that I'm referring to continuously throughout a sequence of learning. And really, making sure once again that we're teaching area and perimeter together. All right, well, that is episode 2 done and dusted. If you have any questions, please make sure you feel free to reach out. Give me a yell on the socials, on LinkedIn or on X. I'm more than happy to have a chat. I look forward to talking to you next time. All right, thank you.